Thank you so much. So so we're currently conducting this research. Is the responder and other roadside worker safety research. So let's start. A little background on this project. The Congress tasked the National Highway Traffic Safety Administration to conduct a study on the effectiveness of several technologies intended to improve safety for incident responders and roadside workers. The National Highway Traffic Safety Administration is working with FHWA, conducting a comprehensive data-driven assessment of policies, practices, and technologies aimed at improving the safety of incident responders and roadside workers. This assessment focuses on move over law compliance and the effectiveness of technologies that have been designed to improve safety. So what is the move over law? The move over law is a traffic safety law that requires drivers to change lanes or slow down when approaching stopped emergency vehicles such as police, fire, ambulances, and in some states, DOT vehicles, tow trucks, and also any vehicle that is stopped on the side of the road with their hazard lights on. The purpose of this law is to reduce the likelihood of responders being struck while working on the side of the road and by providing a safety buffer between the vehicles and the responders. All 50 states have a version of this move over law implemented. However, traffic incidents continue to be a leading cause of death for on-duty officers and roadside workers. The purpose for the project is to understand the move over compliance and technology base struck by crash countermeasures, assess driver compliance with move over law by conducting a data-driven assessment of the move over laws in the United States, and also identify factors that are likely to influence driver compliance. We were tasked to develop and execute an observational research effort to understand factors that influence driver compliance, assess technology countermeasures by identifying current and emerging technologies that influence roadside worker safety, and assess the perceived efficacy of roadside safety technologies. And the result of this study is going to be provided to Congress. So the methodology for this project is a multi-stage effort that's comprised of several literature reviews and data gathering activities to ensure we have the most up-to-date information about the state of the practice. Using the information that we gathered, the team conducted an observational study to assess move over law compliance. And we also had agency interviews to identify technologies that are actively deployed or are currently being considered to improve worker safety. We also sent out a technology checklist to all the FHWA field offices to better understand the use of roadside worker and responder safety technology. And the following 3-4 slides it's a summary of the first task, which is the state of the practice. So the Emergency Responder Safety Institute's struck by database reports that in 2021 there were a total of 65 struck by crashes that resulted in a fatality. This data, while is very valuable, it doesn't cover the totality of incidents since it comes from media reports and is not done by standardized mechanisms. But an important finding is that the large number of fatalities occurred during the day that involve driving distractions and poor driving behaviors, such as speeding, tailgating, and failing to move over. The common factors that influence works on crash severity include works on location, the time of day, and the activity type. The odds of serious injuries for works on crashes are higher during non-peak hours and greater for workers on foot as opposed to workers inside of a vehicle. And overall, the statistics suggest that struck by crashes tend to occur in daylight and in clear weather predominantly. As part of this project, we summarize each of the states' move over law and found that these laws vary highly from state to state. Every state incorporates a speed reduction statute. In some cases, they provide a specific mile per hour reduction in speed, but in others, it leaves it up to the driver to select a safe speed. There's also fines which vary from $25 for a first violation up to $10,000 for injuring or killing a responder or worker. Some states assign points against a driver's license, which vary from 2 points to 5 points. Some states do not specify the number of points that are going to be added to the license. They just mentioned this. And in some cases, there's a mention of a driver license suspension. Some states incorporate jail time for repeat offenses and for injuring or killing a responder or worker. And the jail time can vary from 7 days up to 1 year. There are several factors that influence move over compliance. Driver distraction is identified as a major cause of move over law violations. Drivers crash into incident scenes or work zones due to completing a secondary task, such as looking at their cell phone or interacting with in-vehicle systems or other activities. There's also lack of awareness of this legislation, which is very important. A survey that was conducted by the National Safety Council found that 34% of drivers have never heard of move over laws. Factors that have shown to increase move over compliance are high visibility workers' garment and also high visibility equipment. A study showed that drivers are more likely to comply with move over laws if a law enforcement vehicle is present at the roadside with flashing the red and blues. Also, the number of drivers slow down and move over, the number was high when there were signs reminding of a fine if the law was violated. Also, the studies shown that the messages that contain phrases such as move over, slow down, or move over is the law, associated with reductions in speed and increased compliance, as opposed to signs that only mentioned that there was a work zone ahead. So this is just a quick summary of our background research into understanding the move over compliance, the laws, and the factors that contribute to the compliance of this law. Now I'm going to pass it over to Bob, who's going to present a summary of the observational study that we conducted for this project.
Alejandro. I will talk about the move over observational study that we conducted. This was a field study that entailed passive observation, so naturally occurring incident scenes over about a little over a year. And from the data that we collected in this study, we were able to come up with move over law compliance estimates, and also to do some statistical modeling to determine which factors appeared to correlate best with compliance. Next slide. The video that was used for the study were collected between February 2021 and May of 2022. They do represent live incident scene videos from transportation organizations who provided those as partners in this research. And those videos entailed a total of 8 different states listed here on the slide, and a total of 68 different incident scenes through which about 33,000 vehicles drove through those videos during those incident scene times. The study team developed a tool called the Object Detection and Tracking Algorithm, or ODT, that was capable of processing those videos, tagging all the vehicles, traversing the videos, and identifying whether those individual vehicles either moved over or slowed down. The first step of that ODT algorithm would identify whether a vehicle was subject to the move over law. In other words, whether it was in a lane adjacent to the one where the incident was occurring. So many vehicles are not subject to move over law strictly if they're not in that adjacent lane. And then the ODT algorithm is further able to differentiate whether or not vehicles that were in the subject to the law moved over at least one lane, or alternatively, most laws provide for a provision that if you cannot move over, do not feel you can safely move over, that you can slow down as well. And so you can meet compliance either by moving over or by slowing down. The slowdown number isn't a prescribed number in most state laws. We therefore tried to use a standardized value that seemed reasonable. In this case, the algorithm is tuned to 20%. So a reduction of 20% would be identified for those vehicles. Next slide. So we calculated 2 primary measures for move over compliance. The first measure was whether a vehicle either moved over or slowed down at least 20%. So if a vehicle met either one of those conditions, it was considered to be compliant with the move over law. Then we also processed the data through a secondary measure, which required move over only, also because of what I said previously about the laws vary from state to state, and the slowdown percentage is more of a subjective standard. So we also processed the data looking specifically at move over only. The final number of vehicles that traversed the video incidents that we looked at was 7,831, which were judged to be subject to move over law out of the 33,000 total vehicles. And then we looked at estimating some differential compliance rates and uncertainty bounds for those as well by several important factors. So we looked at cars versus trucks. We looked at rural versus urban roadways. We looked at different incident types, whether it was a crash scene or just a disabled. We looked at responder scene types, whether there's police or safety service or both on scene. And then we also had a traffic flow measure, which we calculated which was the number of vehicles per lane per minute at that scene. Next slide. Our overall evaluation results at the aggregate level across all the 8 states and all the individual incidents was 49% compliance by move over or speed reduction, and 37% compliance by move over only. So those numbers are the total overall result from the entirety of the events in the study. We broke those results down by cars versus trucks. We were finding higher compliance for trucks for move over or slow down or for move over only, either measure. Truck compliance was about 6% higher, 53.7 versus 47 for move over or slow down, and it was about 8% higher, 42.5 to 34.7 for move over only. As I said, those compliance numbers for trucks, about 7 to 8% higher than what we saw for cars, led to an overall statistically significant result that trucks were more likely to comply with the move over law. I'll point out that the statistics that I'm citing here are at the 50% compliance level, and there's a statistical reason for these results. The percentage of compliance differences are going to be different between the low end and the high end of compliance overall in the study. As you get closer to 0% or 100% compliance, the differences between classes get smaller. So I'm reporting the maximum numbers, which are those that occur at about 50% compliance. The second important outcome from this study was that we looked at the vehicles that were on scene. We looked at when we saw that there were police and safety service patrol presence on the scene, we found a statistically significantly higher compliance rate than when you had only one or the other. So police relative to safety, police and safety service relative to just safety service, or police and safety service relative to just police. So when you add that additional presence, it increased the move over or slow down compliance. That's meeting the compliance by either measure by about 11%. The conclusion from that is that the larger number of incident responders or roadside workers on the scene appears to have an effect of making drivers either more willing to move over or slow down, or maybe more cognizant of the scene in the first place and able to recognize that they need to do so. I said previously that we also looked at move over only compliance, and this was one particular category where the outcome had a significant result in one direction. So when there was safety service patrol presence initially at a scene, and then police came on the scene, the overall move over compliance is 24% higher for strictly moving over than the compliance when the safety service patrol alone is on the scene. And the conclusion that we took from that is that the police specifically are more likely to lead drivers to specifically choose to move over as opposed to slowing down in order to meet that compliance. And then the final statistically significant result that we saw from these incidents has to do with the congestion. So we evaluated the number of vehicles per lane per minute at these scenes. It varied anywhere from 2 to 41 across the incidents that we looked at. The statistical modeling showed that an increase of 1 vehicle in the congestion measure, 1 vehicle per lane per minute, was associated with a 2% drop in compliance. So if you went from 10 to 11 vehicles or 20 to 21 vehicles per lane per minute, that would correspond to about a 2% drop in compliance. And that leads to an overall conclusion that increases in congestion are leading to a reduced move over compliance, possibly because drivers are less likely to move over with and more congestion, although they still should slow down. In addition to those factors where we did find significant results, there were several where we did not find any significant correlation. So the rural versus urban roadways didn't show any significant difference. Time of day and day of week didn't show any significant difference. And event type of disabled vehicle versus crash didn't show any significant difference. Now that doesn't mean that there were not or there are not differences there. Just means within the context of the data that we collected and analyzed, we were not able to observe any differences for those factors. Additionally, there were some factors that we were unable to evaluate in our model due to not having enough passive observations that occurred. So we initially included weather as a potential factor, but the road conditions were nearly always clear for the videos that we had. So there was insufficient data to evaluate whether or not there's a specific impact associated with weather. And then the incident scenes themselves, we were also only able to evaluate those which were provided. There were very limited instances where we were provided video that include either fire or EMS on site. So as I previously talked about police and service patrol presence, the reason that those were evaluated specifically is that that's what was available in the videos. And then the final limitation I want to point out with this study is that the 68 videos that we took, although they represent, as far as we know, the largest such study of passive move over law compliance, they still should not be considered nationally representative because they don't cover off all geographies and all roadways, and they were not collected in a random sampling framework. And then the final limitation that's important in the study is that we were not able to evaluate any specific measures from the drivers themselves as far as intent. So we may see that there's a correlation between whether or not drivers moved over or slowed down, but we can't evaluate intent from that. And that concludes what I have to talk about. I'd like to turn it over to Roddy now.
Thanks, Bob. I'm going to talk a little bit about the technology assessment and some success stories that came out of the study to date. So I know we're running a little long here, but let me just go through a few of these slides quickly. But one of the things we wanted to do was conduct an assessment that included a market scan, basically a deep dive literature review, as well as some more in-depth conversations with key stakeholders representing many different organizations, as many as we possibly could, to get a good representative sample nationally. And our focus was to consider technologies that would demonstrate an increase to safety, specifically to responders and other roadside workers. And one of the considerations was technologies that would require some minimal additional equipment, relatively small form factor, though that doesn't apply to everything that we looked at. And of course, importantly, does not interfere with the actual task of responders and roadside worker duties. So the technologies that we focused on included positive protection, and that includes physical barriers, advances in sequential flares and lighting, and that includes newer technologies, LED, lighting that can synchronize themselves, connected vehicle alerts. There's a big advance recently in the use and capabilities of alerts that can come directly from responder vehicles. Equipment that also has the ability to send electronic alerts that can be consumed by multiple recipients, including smart cones. Improvements in wearable apparel and lighting to make it more visible to motorists, for people, responders, and roadside workers who are on scene, and other connected wearable safety devices. Much of the research, of course, and literature that's out there and the market scans that we pursued, of course, focus on work zone applications. There's some general lack of a lot of information related to the use for incident management, but there is more and more technology that is being used to support TIM as well as first responders specifically that falls into these categories. So there is some coming there. It's just not as much as what we have for work zones to date. So some of the technologies that everyone's familiar with, wearable devices, and that includes some connected devices, some that provide greater visibility, but also the sequential flashing lights. And you'll see in the positive protection image up there, there's very large mobile barriers that can be provided to incident scenes and work zones primarily, but also certain incident scenes. And the advent of the connected warnings and technologies are really, really coming into their own these days. And then finally, a little image of the sequential flares that I'm sure people are seeing and using more frequently. So the trends that were identified based on the literature review, the market scan, and conversation with stakeholders, there's a use of traditional pyrotechnic flares, some positive protection and advanced technologies that are taking place in work zones where there's a bit more time to plan for the use of multiple technologies. But there's also been a significant increase in the use of connected devices that can provide real-time information on the status of what is taking place on the roadway, whether it's a work zone and in some cases in TIM as well. Positive protection, of course, is heavily liked, although that provides a unique challenge, because there are cumbersome nature of that and special vehicles that are trailers specifically that are needed to move some positive protection devices into the field, but they are very well liked. 5 agencies that we spoke to directly had mentioned that they had tried work zone intrusion alarms, but that they did not find them terribly useful in every instance. There was a common theme of false positives. In other cases, inadequate warning times. There was a sense that it was not necessarily useful in every scenario or in various scenarios, which limited their benefit. And of course, there were some references to the technical limitations, electrical capacity of some vehicles that are required. The technologies that are required can overpower certain vehicles. That those are considerations that need to be thought through. So, success stories. We defined the conversations that we've had where people have identified very positive responses within the organizations, as well as from the general public in some cases. And we've identified those as success stories. And one of the first ones we want to talk about is the vehicle alerting. There are many agencies that have been deploying alert technologies that are notifying automatically upstream drivers that they are approaching a work zone or an incident scene. And this is the nice thing about these is they're relatively easy to install. Some OEMs and vehicle OEMs are actually building these technologies and alert technologies in, and they are automatic in the nature, by nature of them activating by virtue of the emergency lights. They can be transmitted again very, very easily. And in certain cases, PTC, there was over 4.5 million alerts that were transmitted. Some of these can be customizable alerts that provide a little bit more information to the upstream drivers in their smartphones to give them a bit more information about what the incident or the work zone is that they are approaching, and which lanes that might be taken up, and provide additional direction, which is a bit more specific than a standard move over message. And then, of course, reference a couple other jurisdictions we spoke to that have deployed similar solutions, including Colorado, Missouri, and North Texas Toll Authority. So synchronized lighting technologies, there's been a number of agencies that have reported successes in taking advantage of computerized synchronized lighting, and that includes flares, but also lighting on the vehicles. We have a great opportunity to leverage some of the lighting technologies that are out there that companies are developing that can synchronize across vehicles, not just across the devices automatically, and provide patterns that provide or enable motorists to have, in a sense, more visual clarity about what is the situation that they are approaching, whether it's a work zone or an incident, and even see visual direction regarding which way they should be moving over in those particular instances. In Colorado, the Department of Transportation has synchronized lighting across multiple snowplows so that when they are in operation, they appear as almost a single visual cue and visual alert to motorists so they can see exactly in better detail visually what they are approaching when they see a plow, a group of plows that are operating together. Illinois State Police has implemented some customized lighting patterns that they believe is definitely resulting in some improved motorist awareness and behavior. And those are dynamic, and they can change patterns based on speed and response type and physical location. So there's a lot of capability that is now coming into lighting that we think warrants some greater attention and provides some opportunity. Mobile barriers. So unlike the others, which can be automatic and small in form factor and easy to deploy, mobile barriers, of course, are more challenging, as mentioned, but they provide a pretty important physical separation. Typical deployments, as mentioned before, are work zones, but for long duration incidents, crash reconstruction, some jurisdictions are deploying those. Again, they're cumbersome, but they provide extra benefits, not just the physical separation between those, the responder and the roadside worker, but they also eliminate some degree of rubbernecking due to the fact that the motorists who are passing cannot visually see what is being either worked on or responded to. So there's a general positive response to these physical barriers. The biggest considerations and limitations of these is that they are cumbersome. They're also expensive, but that is the primary consideration there, but the reports are very positive for their use. And I'll wrap up next steps. What we're going to be doing next is providing the results of the study to Congress, and which will be shared nationally. And so we're working right now on finalizing a series of reports that'll be made available to all. We're going to work on a more in-depth webinar that talks a little bit more about the effectiveness and the results, looking at later this year, early next year. And some additional analysis we think will be needed to assess the efficacy of the practices and technologies, to look at move over law compliance. And the laws, of course, are evolving. We're here at the university in Maryland. We are changing our law in the state effective actually this Saturday. We're going to be requiring the law in Maryland, like in other jurisdictions, is being updated so that any vehicle at all that is parked or has any kind of warning lights, including regular vehicle hazard lights, will require move over action or a speed reduction by passing motorists. So there are big opportunities, I think, to look at how some of those evolutions of the statutes are changing motorist behavior and seeing the results there. So, and with that, I think we are wrapped up.